All right, everyone. Welcome to the first workshop of the quarter for learn.py. If this is your first time with Hack, welcome. We're happy to have you. If you've been to previous workshops before, welcome back. Again, we're also happy to have you. I'm one of the co-directors, Nari.
And I'm another co-director, I'm Einar.
And let's get this started. Okay. So if this is your first time at a Hack event, feel free to use these slides, for anyone, feel free to use these slides if you want to reference them later. We also have a README on GitHub, which has the same info that's on the slides as well as what we talk about and examples. So I'll give a few seconds on this slide. Okay. And if this is your first time at a UCLA ACM event, we have a membership portal where you can earn points for attending these events. This workshop's code is anyone can code. If you've seen Ratatouille, it's a plane on anyone can cook, one of the books. Additionally, we have a feedback form for each workshop. You can also find the link on this slide. And with the feedback form, we will be doing a raffle. So you have a chance to earn some money. Yeah. Right. We have it in chat as well if you need it for reference. All right. So since this is the first workshop, let's give like a brief overview of what we're going to cover throughout this entire series. So you're at the first session. So today we're going to be doing Intro to Python. But as we go on, there's more stuff we'll be going through. After the fundamentals of Python, we'll also be going through applications where you'll get a little bit of a deep dive of Python and what it has to offer. So before we get started, we just want to do a quick poll of what classes you've taken at UCLA that are CS related. Reason we're asking for this is because we do recommend that you have taken CS31 or PIC 10A or an equivalent, because we will be going over the tiny details of some of the basic concepts. We just want to show you guys how to do those kinds of things in Python. Of course, you're still welcome to join us, but we will be going at a little bit faster pace. So let me launch that poll. And if you haven't taken them, feel free to, I suppose, not do the poll, and I'll be able to see out of the participants who has not. Just give a couple more seconds because most people have voted already. Okay, so majority of you have taken these classes, so that's good to hear. I won't share the results just because it's a little bit more personal, but just be aware that, again, if you have not taken these classes, we will be going at a slightly faster pace. So just be aware of that. So what are we going to cover in this workshop specifically? We'll be going over, how to get Python on your computer and what the interpreter is and how to use it. How to use variables in Python, so the many different types. And then we'll be going over some conditionals, loops, and functions. As always with every Hack workshop, but if you haven't been here before, please know that this is an environment where you can ask questions. If you're confused at any point at all, feel free to drop a question in chat. Either I or Einar or one of the other Hack officers will be answering the questions in chat. And feel free to ask any questions at all throughout any point. There will be moments where we'll pause where we can answer it verbally, but don't be afraid to drop questions in chat at any time throughout the entire workshop. So the question on everyone's mind, if this is your first time, what is Python? Well, it is a snake, but I don't really know much about the Python snake. I do know that it can swallow, or I suppose it can eat a deer and a boar whole, which is a scary idea, but that's about the extent of my knowledge. So that's not what we're here to talk about today. What we want to talk about in terms of Python today is the Python coding language, which I think is much cooler than the snake. Sorry if you're a Python snake enthusiast, but I really think that this coding language will be one of your favorites once we're done with this series. So there's a lot of technical definitions for what Python exactly is, but just like on a really high level, Python is one of the fastest growing languages amongst many audiences, not just software developers. And this is because it's really great for many tasks other than creating software, such as data analysis, AI and ML, which stand for artificial intelligence and machine learning, and automation, which, as a hint, is for a future workshop. So if you want to learn more about that, please tune in for that one. So why do we use Python for these tasks over other ones? There's a lot of reasons, of course, but some of the key points is that large and complex problems in Python can be done in simpler and fewer lines of code. We'll see later with some examples, and in future workshops, you'll also see how simply some tasks can be done within Python. If you've done C++ before, which the majority of you have, or any other programming language, there's a lot of different kinds of coding styles as well, such as having to put semicolons and curly braces in C++. Python doesn't have that, and we'll go into what we use instead of that, which I think can, in some cases, be a lot better to use, which is why I put awesome coding style. Additionally, you can create and run Python applications on any device. This means it is cross-platform. So whether you're on Windows, Mac OS, Linux, or the operating system of your choice, you can create and run Python applications. So what we'll be using today to display some Python code will be within a text editor called VS Code. If you haven't heard of a text editor before or haven't used VS Code before, you can simply run any kind of, you can simply put any kind of programming language or anything of the sort and type it up and run it. Idle, we'll get into a little bit on what it is, but we'll be using that as well to show off some Python code. Before we get into some of the more technical stuff, are there any questions so far about Python itself or this workshop or anything at all? Okay, looks like the chat's good for now. If there's any questions, of course, there'll be more opportunities, or one of the officers will be happy to answer them as well. So I've shown you these text editors in Idle, but we do not recommend coding along for this workshop. So while I will show you how to get these on your machine, we highly recommend that you do not code along with us. Reason being that we'll be going through a lot of content, and since this is just like the first introductory session into what Python is like and how you write certain things in Python, it is best to just absorb the knowledge because we'll be going through a lot. But if there are any questions, feel free to ask in the ACM Discord. Or alternatively, you can also find this information on the README in the future. So how do we actually start using Python? So one of the key things is that you have to download Python. And there's this, python.org is really your main hub for all things Python. I'll go into it a little bit just to show you, because it can be kind of confusing if this is your first time actually downloading, I guess, a language off of a site. But you just want to download the latest version, and Idle, which again, I'll get into what that is and what the interpreter is in a little bit, will be installed with this as well. So let me just quickly go into the site just for demonstrations purposes. So you'll see that you get on this little landing page. The button here is for Windows download, but if you want to run on Linux or Mac OS, you would simply click on this and you'll see the latest releases will be under here, and you can download whichever installer is best for your machine from that point. So it's as simple as that. It's also on the README as well, if you would like to reference that later. As far as the interpreter and Idle, I do mention here that if you want to use the interpreter instead of Idle, reason being because the interpreter is directly inside of your terminal while Idle is its separate application, you can run the interpreter inside of your terminal using py on Windows or Python 3 on Mac. For our purposes, though, they will act the same. So once I get into the explanation for idle, you can assume that some of the basic stuff for that will also transfer over to the interpreter. So what exactly is idle? I've been throwing this around, but if this is your first time hearing it, Python's idle is the integrated development and learning environment. So what exactly is that? It's a good place for testing and experimenting code. And it runs under something called a read, evaluate, print loop, shortly called REPL. So what this does is it reads the current line of code that you put on it, then evaluates that code, then prints the result of that on the screen, and then loops back to read whatever the next line of code and whatever you decide to input. So where do we put that code? Well, there's something called a Chevron Prompt, which is just a fancy way of naming those 3 angle brackets or those 3 arrows on the left of the screen. All of the entries that you put, so for example, as you can see, I put a variable in there called x, and we'll get into what that is in a second, but you can see that even though I put that on a previous line, it's still saved until we restart it. For just this demonstration's purpose, it does have other applications as well, but just for this demonstration's purpose, we'll be mostly just using it to show some examples of Python code. So it just lets us easily run Python code really quickly, rather than compiling a larger project within another IDE, such as if you did C++ for CS31 within like Visual Studio, for example. So that was a lot of information. Before we get into the specifics of like the Python language and how we can start writing code, are there any questions about the anything at all? Installation process, idle, interpreter, and also this is just a funny Python meme. I have to fix my posture as well. Yeah, I'm always like really aware of my back. Yeah. Okay. If there's no questions for now, we'll get into variables. Ooh, fancy word. Since many of you have taken CS and some CS classes before, you might know what variables are, but what do they look like in Python? Well, just like a brief overview, again, variables are a space in memory that have a certain value, and we give it a name that we use to retrieve its value later on. So again, we'll get into what exactly this line of statement is doing here, but for now, we can look at it like this. So Remy is the name of our variable that we want, and chef is some value that we want to give it. You might already know what this value is, but we'll get into, once we get into some of the syntax, you'll know what exactly this value is and what it means for this variable. But for now, this is how you create a variable. You simply give it a name and assign it some sort of value. And with most programming languages, you always want to give meaningful name for your variables, while also not having it too long, because you want to use it later on for like ease of coding. In Python, convention is snake case. So if you've used C++ before, it's most likely that you've used camel case. But convention, meaning what's commonly accepted as the best way to write Python code, is to use snake case. So each word is separated by an underscore. And in Python, the type of the variable is not specified. As you saw with the previous example, we simply had the variable name. We didn't say what type of variable was. And that type can actually be changed later on, which is, again, another reason why we want to give meaningful names. So what kind of types can our variable have then? Python is really similar to other languages in what kind of variable types we have. But today we'll specifically cover numbers, strings, lists, and Booleans. And Booleans will be in the second half of the workshop. For now, we'll be focusing on numbers, strings, and lists, but just wanted to show that that's also a variable type that you can have. So let's get cooking and look into what these variable types are. So something that's really common across many programming languages are these two types of number types, int and float. Int stands for integer, and it's just whole numbers. For example, in the example in the bottom left, you'll see that, for example, number of friends that I have is 0 because I'm very lonely, and sheep counted equals 4,326 because I can't sleep at night. No. So there's some sort of positive and negative whole numbers. Floats, consistent with most languages, are just decimal points. Again, can be positive or negative. So for example, your GPA is represented as a decimal point. Unlike C++, there's no doubles, longs, or shorts. Some of that is done under the hood, but yeah, there explicitly you only have ints and floats, and we'll see that in a little bit. So with numbers, of course, we want to do some sorts of arithmetic operations, some like adding, subtracting, that sort of stuff. So exactly what can we do? Like I mentioned, addition and subtraction, pretty consistent with most languages, plus and minus sign. Multiplication and decimal division. And we'll see in a little bit why I specified decimal division. If you did C++, the division operator will always do integer division unless you use some sort of double or float. But in this case, regardless, it'll always be decimal division. However, if we want to do specifically integer division, and we say floored because it rounds down always, you will use two forward slashes. And for exponentation, we put the two asterisks, with the left side being the base and the right side being the power that you want to exponent it to. And modulus, which is consistent with most languages, is, again, the remainder for division, is the percent operator. So before we continue on, let me show you some examples, and let me actually go into idle and show you what it looks like. So in my screen, I can type idle here on Windows if I want to bring it up. If I was in Mac OS, I would do idle 3 inside of the terminal. It's a little bit more hidden, but I have it open here already. So we can look into some operations here. Again, this is the Chevron prompt, so I'm going to type in here. So I can just do some basic operations just to show how it works. Remember, it runs under a read, evaluate, print loop. So whatever I type, it evaluates it and prints it on another line, and then goes back to look for more input. So just testing some basic operations just to show what it looks like. That was subtraction, we have multiplication. And again, it's usually convention to put a space between your operators for legibility. We can also multiply by some sort of decimal / float value, and we'll get a decimal number in return. So again, a point of contention or something to be aware of for division. Even though we put integers in, it will be a decimal division. We get a float value in return. And if we do 9 divided by 4, oh, sorry, can't type. 9 divided by 4, we'll get a decimal. If we wanted an integer, again, use two forward slashes to indicate that we want integer division. And it will round to 2. Again, it rounds down. So it regardless of what the number is. So again, let's say I have some sort of variable, integer variable, x. Again, you don't put the type, you just put some sort of variable there. So x equals 7. And there's something nifty you can do called type. And you simply just put the variable or even a number or whatnot inside of these parentheses, and it'll return what kind of type that variable or whatever you put is. In this case, is an int for integer. So if we have this integer x and we divide by 4, we'll get the decimal 1.75. Again, remember, if we do two forward slashes for integer division, it'll round down to 1. So normally we would round to 2 if we were doing it by hand, but Python always rounds down. Again, for exponentation, we can simply just do 2 to the power of 3 with 2 asterisks, and it'll be 8. And we can also take our variable and do the same. All right. Are there any questions at this point about anything at all? just go through chat. Is there a way to round up? I'm not entirely sure if an officer could answer that, but as far as the basic operations go, this will round down. Okay. For those watching the recording, you can use the ceil function to round up. And we'll get into what functions are as well. Sorry, I kind of threw that word in there, but we'll get into what functions are later in the thing. Okay. Looks like we're good for now. I'll take breaks across every type that we go through, just because it's a lot of content at once, and I'm aware that going through it kind of fast as well. So next we have strings. So strings, which is pretty consistent with most languages, just can be any single letter, words, sentences, or any big blocks of text. So something in Python that you can do, either you can put it in single quotes or you can put it in double quotes. And if you want to do multi-line strings, you use triple, single, and double quotes. And we'll show you how it looks like in a little bit. So just an example, for example, if I wanted to use a single quote string, just put in single quotes. Double quotes, I put them in double quotes. Whereas in multi-line, I would need to do it with 3 either single or double quotes. Doesn't matter which one you use, so long as you begin and end with the same ones. And a big word here, string concatenation. Strings can be concatenated, which means they can be glued together or put together using the plus operator, or just by being put next to each other. So just as 2 examples here, using the plus operator, we can put I like Python, and it'll give us I like Python. Similarly, just putting these 2 strings next to each other, we can get I like Python with the same thing. And the concept of putting them next to each other is called implicit concatenation. You can also repeat the same string using the star operator or the asterisk. So however many number of times you want to do it, times the string will output that string however many times you put it. So if I wanted to output hack squad 3 times, it'll output hack squad 3 times. Okay. Sorry, before I get into that, let's look at some basic applications with strings. And I'm just gonna hit enter a few times just to separate it. I'll also show how to go around idle just a tiny bit, because it's kind of hard to see what I'm doing as well. But let's say, let's make a string variable. So I have a variable called my name, and my name is Nari. So it didn't output anything because it was just simply assigning it. So if I wanted to see what the name looks like, we can just simply type my name. And remember, this is just something we can do inside of the interpreter. If you were actually writing Python code, you would need to output it in a certain way, which we'll see in a second. But if we just wanted to do it like this, we could see what the constants of that variable are. And we see it's my name, Nari. We can also run type on this variable as well to see that it's str, which stands for string. So this variable is of type string. We can also make another one called a cooler name equals anar. Click enter. And again, if I want to see what it looks like, just type it in there. I have anar. So if I wanted to add them together, we could simply do my name plus a cooler name. And we'll get anar. Additionally, and just before I do this, I'm using my arrow keys to travel around idle. So it's kind of hard to see the cursor, but I clicked the up arrow twice to go back to this previous line, and I clicked enter to bring it down. It's really easy to make quick changes if anything gets messed up. I believe you can do this as well. Oh, you cannot. With variables, you cannot. But remember, if I do something like this, this does work. Just reason being that with variable names, it's kind of hard to tell. Whereas with plus signs, you can do that. But if you do literal strings, we can actually concatenate them by putting them next to each other, implicit concatenation. Let's try to repeat my name multiple times just because I have a big ego. No, I don't, but let's just try to do that. It can do 10 times my name, and we'll see it's just repeated 10 times, quite literally, just my name repeated 10 times. If I try to do something like this, however, now this would not work. Of course, it doesn't really make sense to multiply two strings together. So if you do use the multiplication operator, do make sure that your has a number on one side. All right, next thing that we can do is do this. Now, I have a couple quotes that I have. So let's just say Nari says, Einar is super awesome. And you can already tell by the highlighting within idle, which is really convenient, that there's an issue with this, but let's see. All right, it said invalid syntax, but I ended with a double quote. So what's wrong with this? So let's see. How can I put quotes inside of my string? This is where, spoiler alert, looking at the slides, something called escape sequences come in. So like we saw before, if we want to put some speech inside of a string, such as this, as Remy says, changes nature, you'll get an error. Instead, we use something called escape character. In Python, it's a backslash to put in these special characters. So if we wanted to put a quote in, we could do, as Remy says, backslash, and then the single quote changes nature, backslash single quote, and then end again with the single quote. The reason it gives an error is because Python will read until the next single quote, which is right before change in the previous incorrect syntax. Incorrect syntax meaning you incorrectly used the punctuation. And so we'll get an error otherwise if we don't escape it. And we'll see in a little bit, this is really convenient for certain sequences, such as the new line, which just prints the whatever follows that on a new line, or a tab, which just works as a tab with its \t, or two backslashes to put literally a backslash within a string. If we didn't use the backslash, if we didn't use the escape character, then we would just have the letter N, the letter T, or the backslash by itself would be looking for something to escape. And we call these together sequences. The backslash itself is the escape character. Okay. So let's see that work for our example. So again, I'm just going to click enter a few times just so we can separate the previous example. If I want to put that Nari says Einar is super awesome. Oh, actually, I do want to bring this down. So I'll use the up arrow to go up a couple times and click enter to bring that back down. Where we had this first quote here, I'll put a backslash to escape that quote so that Python knows, hey, I want this to be a literal quote inside of my string. And we'll do it again here. So now you see it can actually read it as a quote inside of the string. And this is really convenient for stuff like this. If we wanted to do a name mashup, so again, going back to the basic concept of strings, if you want to do a multi-line string, you can put two single quotes or double quotes. Again, they're kind of interchangeable in this situation. We can put that Nare, and then I'm going to click enter. Notice it didn't give me an error yet because it's looking for me to finish my string. So I'm going to do plus Einar equals Narna. And I'm just clicking enter to put them all on different lines. Again, I'm going to close with 3 single quotes. And once I click enter, it'll know my string is done. So let me view my string now. You can see the backslash ends wherever I put a new line. But what if I wanted to see what the string actually looked like? Within idle, you can put in these variable names. Within an actual Python development environment, you can't put in these variable names to see what it looks like. But let's say in idle, how would I want to look at them? Or if I'm actually developing Python, how would I want to see something on my screen? Well, this is where some basic input and output comes in. So print is kind of the most basic way to put some text on the screen. Print lets you put anything inside of the parentheses and it'll output it. So whether you want to put a string, it'll say hello. If you want to put the Ratatouille release date, you can get the Ratatouille release date on your screen. And again, you can pass any value and any variable to print it. Another thing, so sometimes we want to see what the user, we want to use something that the user gives us in order to display that on the screen instead. Well, input is pretty simple, just like print. So we want to put in the input inside of a variable. So the syntax for this would be to put the variable name and then equals and an input, the input function. Again, we'll go over what functions are in a second, but input and then parentheses and then put some sort of prompt in it. Now the prompt isn't mandatory, but it's really nice to give a prompt to your user so that they know what exactly you're asking, because otherwise it can be ambiguous what you're asking. So let's assume I put some sort of prompt. Now the prompt will be displayed on the screen and the user will enter an input, and variable name will now store whatever the user has entered. Again, you may also leave the input blank, but it's really helpful to have some sort of message in there. And it's really important to note that input is stored as a string inside of your variable. So even if they input numbers, it'll always be stored as a string. Okay, so let's see that as an example. Well, first, again, I wanted to print name mashup just like how I put it in. So let me just put name underscore mashup. And we can see that it took the \ns, which would normally mean a new line, and quite literally displayed those on the new line. Again, I just want to make it very clear that just putting the variable name won't work in a development environment. You do need to print if you want it to be displayed on a screen. But since we're inside of idle, I'm able to use the variables because it's a quick and easy way to test Python code. But if you want it to be formatted within idle as well, you will need to print whatever you want. You will need to use the print to print whatever you want, quite literally. If you've written in C++, you would know that printing a string might take a lot of lines of code. You have to import IOStream and then make the main function. Well, in Python, it's as simple as just doing print hello world. And it prints hello world. So this is what I was saying earlier with, it's really easy to do more complex things with simpler lines of code. I mean, this is a basic example, but it really starts adding up as you go along. Let's see more examples of print. So I really like cheese. So I'm just going to say that Nare likes cheese. And remember, you can put \ns or any escape sequences inside of your string. Alternatively, you can use multi-line strings, but let's just say I wanted to do that I like cheese with \n. If I print the variable out with an idle, again, like we saw with a name mashup, it'll just print the \n. But if I want it to be displayed on the screen properly, let's do print cheese lover, and it'll be printed on multiple lines. Now, seeing what inputs look like. Let's say I want to make a program and I want people to tell me their favorite cheeses because I want to start a cheese club. So let's make a variable, favorite cheese. And remember, the input needs to be stored inside of a variable. So we'll put input, and I'm going to put a prompt because I really want my users to be able to see what exactly I'm asking for them. So what cheese do you like? And you'll see while I put the semicolon in a second. Now, once I click enter, it'll directly give me the prompt. So again, it'll evaluate and see that, oh, I want some input. Okay, so I'll put it on the screen. And on the same line that you had it, you put the input in. So I can really put anything in here, but I'm a nice user and I want to give legitimate answers. So I'm going to put pepper jack. All right, well, we put the input in, but we don't really see anything on the screen. But what's happened is that pepperjack has become a string and been put inside of favorite cheese. So now if we print favorite cheese, oh, sorry. And I just went up and clicked enter. We'll see that favorite cheese is stored within pepperjack. You can also do it again without any sort of input, and you would simply do it like this. No prompt at all. You could just put input. Sorry, I misspoke. I said without any input. I meant without any prompt. And it will just look like this. It'll just be on a new line. But again, it's really hard to tell what the maker of the program is asking for you. But I'm just going to put American cheese. And if we go up and try to print it, we'll see that favorite cheese now has American cheese. So as far as basic input and output, that's all it goes. And we can head on to the next session. But before we go on, I know that was a lot of content and I went kind of fast with strings. So are there any questions before we move on to lists? Yes. So anything that you put, so the question was, is your answer to an input prompt always seen as a string? Anything that you put, as far as the way that we've done it, anything that you put inside of input. So let me just go back to idle really quickly. When I typed something here as pepperjack or American cheese, that got saved as a string. And I can show that again with type, which I probably should have done that, but I'll just do that now. It was saved as a string. If I do, for example, favorite cheese input, and I just won't put a prompt because I just want to show. If I put the number 9, for example, doesn't really make sense as an answer, but if I just did that and then I did favorite cheese, it'll still be stored as a string. So in this situation, with how we put input, regardless of what you put in, it'll be stored as a string. Yeah. Any other questions? And also feel free to drop them as we go through. Just for the video, someone mentioned that if you do want to get an integer, you could do the input and then wrap. Actually, let me just type this out, would be better. Just to show, so we have it on video. You could say my number equals int, and then we put this in here and then put our input in parentheses like this. Put number 9. Oh, did I? Yeah, sorry, I forgot something at the end. Sorry, what mistake I made there was I forgot the closing parentheses. But if I put the integer again here, you'll see the prompt that says enter an integer. I put in the number 9, and if I do type my number, it'll be an integer. There we go. Any other questions? Okay, all right, let's move on. So lists. Oh, that is one slide ahead. Okay, so what are lists? Lists allow us to save a group of ordered values. That's very similar to an array in C++ if you've worked with it before. You can put different types into the same list. So this is where it differs with C++. You can put different types into the same list, but commonly and ideally, you would have just one type for all elements. So for example's sake, let's take my favorite numbers. So how you declare a list is just you put the variable and then in square brackets, you put whatever elements you want. So let's say we have my favorite numbers. You can also replace a certain value using its index. So again, just as a refresher, index is the location of a certain value. And in Python, we start as 0 as the first position. So if I no longer wanted the number 5, this is where it was originally. So this is the list that we have currently. Then we do square brackets, and then we put the index of that number. So starting at 0, 0 would be 24, 1 would be 1, and in index 2 would be 5. So we do 2 equals 3. So we assign the value 3 into my favorite numbers square brackets 2. And now we'll see that it would be replaced. You can also add new values to the end of a list using append. And so let's say I really like the number 7. So using the same example I had before, so using my changed list, now I can do dot append to the variable name, dot append, and then in parentheses, whatever number I want to add. Or really, you can add anything, but I want my favorite numbers, so let's just add the number 7. So now you see, it is added to the end of the list, and while the rest of the numbers preserve their order, because again, lists are an ordered sequence of any items. Okay. Before we get into that, let's look at list really quickly. So I can bring my favorite numbers back just for the sake of example. And I also want to show that we can just start with like one value. So we can just say 24 for now. And then this will be a little bit tedious, but I can just do dot my favorite numbers. So the variable dot append whatever numbers. So I had 1 in there, and then I'm just going to do an up arrow and copy this so I don't have to type it every time. Then we added 5. And just to show that these are being added, we can do this. And with the print, you can also do the same thing as well. For our purposes, it will print the same thing. But again, if you wanted to print on the screen for a user outside of idle, then you will need to use print. So again, let's add the number 100. Okay. Just one last time. We can see that now I've put inside of my list 24, 1, 5, and 100. And if I do type my favorite numbers, you'll see that it is indeed a list. So let's see what else we can do. We can do a replacing. So we can change a certain value inside of the list using its index. So let's say I want to change the first one, which is currently 24, to 20. So since it's the first one, we put index 0 equals 20. And if I print it again, it'll be 20, 1, 5, 100. And now let's change it up a little bit. Instead of integers, let's do some phrases, right? Everyone likes using phrases on the internet, so let me do my favorite ones. My favorite ones are uwu and owo. Don't come for me. I think they're really awesome. So let's print them again. And we'll see that we have uwu and owo in the list. Now let's append another one. It works a similar way to other ones as well, but let's just do awesome sauce. I say awesome sauce a lot, but my friends laugh at me for it, but I think it's kind of cool, so I'm going to put it here. These are my favorite phrases. So again, you can append really anything into this list using the dot append. And again, we can replace it as well. So let's say I want to replace OO because it looks like a face and that's kind of scary. I'm going to put Pog Eugene. Again, I'm really sorry, Eugene, but your legacy is living on. So if we do that, we can see that Pog Eugene has now just taken a place. Taken OO's place. And just as a reminder, you can intermittently, or you can mix up whether you want to use single quotes or double quotes. In this situation, they will have the same effect because they both represent a string. Okay, now that we've shown that we can do this with numbers and arrays, or numbers and strings, let's get a little crazy. This is where it differs from C++ arrays, because you can't have different types. Let's just say, hint, this is going to be a random type list in C++, or at least within the classes that we've had. So let us try this out in Python. All right. So let's put string first. Remy the ratatouille, and I hope I spelled that right. Ratatouille is kind of hard to spell. And then we'll put an integer. So the first one is a string, second one is an integer, and third one we'll put a float. Okay. And if I just print this out, we'll see. We can still make this list. It'll have Remy the ratatouille, the number 12, and 15.7. And let's get even crazier. Let's put a list of lists. So we had my favorite numbers. And in this case, since we have the list, we can put the variables and it'll know it's exactly we're asking for the list. So my favorite lists are my favorite numbers, phrases, and random types. And if we print my lists, we'll see that instead of displaying the variables, it'll actually print out the entire list themselves. And again, you can switch these out with whatever is necessary. So that's like a quick intro to lists. Are there any questions so far before we go into the last part of this section about variables? Okay, looks like there's no questions for now. So let's continue on. So the last thing I'll talk about in terms of variables, and something that's a very important, but albeit can be kind of confusing concept, is mutability. So what does it mean to be mutable versus immutable? So some types that are built into Python are mutable while others aren't. And to be mutable means that it can be changed after creation from its initial state. And to be immutable means that it cannot be changed. But what exactly is being changed? Let's get into it. So, well, before we get into it, sorry. Some of the types that are immutable that we've gone over are int, float, and string. And whereas the list that we went over is mutable. But couldn't we change the value of an int or a string variable or change it into another type? Because as you saw, for example, with the numbers, we could change it to some sort of different number, right? So doesn't that mean that they are mutable? Well, yes, but that shouldn't be mistaken for mutability. Being mutable does not mean that your value is constant. So then what exactly is mutability? Oh, that's strange. Okay. Something's happening. Oh, okay. I'm not sure what happened there, but all right, this is the slide. So let's look at ints, for example, which are immutable. So we have the number x, and we put 5 in it. And then let's say we have another variable y, and we put x. So y equals x. Then we change x to equal 7. Well, in this case, y still equals 5. So what does that actually mean, though? Because that can also be a little bit confusing, right? Because then it's like, but I thought ints weren't mutable. So why was I able to change the value? Well, let's look at this within idle, because we'll be able to get a clear picture. So let's say x equals 5. Then we put that y equals x. And there's something that you can do within Python called ID. And it'll give you the, for lack of a better words, the identity of that variable. So as we can see, because they were put equal to each other, they are the same, I suppose we can say the same thing. If you've taken CS32 or 31, you can think of them as the same object. X and Y point to the same object. All right, but then what happens if I change X to be 3? Well, we know that Y will still be 5. That doesn't change. So what did change? If I do ID of X, oh, this is a different number. So the identity of X has changed, whereas Y, I know it's a lot of numbers, but if you match them up, they're the exact same as it was before. So when objects are immutable, a completely new, I guess you can think of it like a completely new variable or a new identity is made for it. And this can sometimes be costly because you have to make a new one each time you want to change it. Whereas, and if we look at lists, I'm going to have this issue again if I start on this slide. Okay, hopefully this works. Yes, great. Okay, whereas lists in comparison are mutable. So let's say we have some list Y. So if we do y.append 3, and then let's say there was some other numbers in there, and I wanted to change the second element. So we wanted index 1 to 7. When I do these operations, they can be done directly without needing to reassign our list to an entirely new list. So they don't need a new identity. So again, let's say I have some list, 1, 2, 3. And let's say I put some list into X as well. So X and some list are the exact same list. If I add 7 to X, some list will also have 7 added. So this is a property of mutability. You don't need to create an entirely new identity. So let's look at that one more time within idle. So we saw that with immutable objects, their identity is changed, right? So let's look at lists one more time. So if I have my list and I equal it to 1, 2, 3, just a simple example, and I have some list Z equals my list, we can do ID again to look at the identity of the object. We see that they're exactly the same. Now, what happens if I do append 7? Well, if I do print Z and print my list, they're exactly the same, just like we expected. But what about the identities? Because I made a point about with immutable objects that their identity is changed. Well, as we see with Z, it's exactly the same. So we can expect my list to be exactly the same. So with immutable objects, they don't have to have an entirely new identity every time we change different objects. If I did the same example that I did with integers to strings, for example, it would also work the same way. All immutable objects would have a new identity every time they're changed. So it doesn't mean that it's constant, rather that the identity is changed. And as we continue on, this is really important to know. So let's see. Right. So being mutable means that you can change its property without changing its identity. And again, I just want to stress that it does not mean that the value of the variable is constant. It just means that the identity does not need to be changed whenever the value is changed. All right. That is a big topic. So if there's any questions, feel free to ask them now before we get into the final poll for this section. And again, if any questions about this come up later on, you can always ask in the Discord on the hack channel as well. Okay. If there are no questions, then I'll go ahead and launch the poll. This will just be kind of like a refresher of what we went over in this section. So I'll launch it now.
Here we go. All right, welcome back. Hope that break was relaxing. But let's just get right back into it. So first up, let's talk about conditionals. And if you've seen conditionals in other languages, conditionals in Python are definitely not going to surprise you. So yeah, we'll just zoom through this, get the pace going pretty fast. So yeah, this is the most basic form of an if statement in Python. You can see it looks pretty similar to other languages. There are a couple minor differences, So let's take a look at some of those differences. So first of all, parentheses here.
Sorry, the music is still running, by the way.
Oh, yeah, my bad. 1 second. I completely tuned it out. Here. Okay. So like I was saying, yeah. Okay. So parentheses are optional. You don't need parentheses around your Boolean expressions like you would in C++. And unlike C++, you don't need curly brackets to indicate where your body of your loop is, of your if statement is, right? So in fact, if you put curly braces here, you will get a syntax error. Depending on your preferences, it might be a good thing, it might be a bad thing, but it is what it is. In Python, there are no curly braces. So keep that in mind. Instead, what we have to replace curly braces are this colon here and the white space, right? So in Python, unlike other languages, this might not be, you might not be familiar with this, but white space is what you use to indicate what's part of a if statement, right? So to indicate what's part of an if statement, you just have either a tab or 4 spaces. The Python documentation recommends you use 4 spaces instead of a tab. I don't want to start a flame war or anything, but personally, I like to use tabs just as long as you don't interchange them. Just keep consistent with whatever you choose. Either tabs or spaces, don't use them both. Okay, so it's up to you what you use. And again, I do want to reiterate that white space really matters. So these two blocks of code look pretty similar at first glance, but you can tell from these statements down here, this one is indented with a tab, and this one is not indented. So this statement belongs to this if, it's within the body of this if statement, and this one is outside the body, right? So this will only get executed if this is true, and this will get executed regardless of the value of anyone can cook, right? So yeah, white space matters. And just a quick aside, Python has the same comparison operators you're used to. So less than or equal to, greater than or equal to, etc. They're all here. They all work exactly the same way as they do in other languages. So yeah, keep that in mind. There is one slight difference with Boolean logic in Python, and that's that the logical and, the logical or, and the logical not are all indicated using just the word and, the word or, and the word not. So that's, personally, I like that. I think it's better and more, open to other people. It makes it more readable to just have English in there. I don't know, maybe you're different, but I think it's nice. So yeah. And one last thing, this one, you should definitely keep this in mind whenever you're using conditionals in Python. Values can be either truthy or falsy. And what that means is that whenever there's an expression in Python that is expected to be a Boolean, so, for example, in an if statement, that value, if it's not a Boolean, it will be converted to a Boolean value. So for example, empty container types will be converted to false, and 0, the number 0, will always be converted to false as well, indicating that it is falsy. And here's a chart of some types to go over that. So true is obviously truthy because it's true. False is falsy. The number 1, since it's not 0, is going to be truthy, so it is converted to true. The number negative 12,123, it is true. It's converted to true. The number 0, since it is 0, is converted to false. And these are 2 empty containers. So a list is a container type. A string is also a container type. There are a couple more that we'll go over later, but for now, this is all we have. So lists and strings, those are empty containers. So they are converted to false. And then this is a list with some values in it. This is a string, rat-tat-tat-tat. It's not empty. It has some stuff in it. So they are converted to true, right? So truthy and falsy, that's what that is. Okay, back to if and else. So else is also here in Python and works exactly the same way with the caveat of all that Python specific stuff. So keep that in mind, but it does work more or less exactly the same as the if up here, except there's no condition, right? So that's nothing new. Okay, Elsif is a little bit different. So this is Elsif in C++. And the reason it's different is because in C++ specifically, Elsif is not technically a keyword, right? It's just a combination of the else keyword and the if keyword. So these are technically two separate statements. This else, or this if here is nested within this else, as is this else. So these are all nested. And the reason you can get away with that is because white space is ignored in C++, right? So you can, like, even though it's kind of deceiving what's actually happening, it looks nice, it looks pretty, and we like it, right? Unfortunately, a problem arises in Python due to the fact that white space is not ignored, right? We do care about white space in Python. So here's a direct translation of this C++ code into Python. So here's what that looks like. So this if up here corresponds to this if, this else corresponds to this else. And like I said, this if and this else are technically nested within this else. So you can see that that's what's happening here. This if and this else are nested within this else statement up here. But this looks terrible, right? This is not what we want to do, especially when it comes to getting more complicated chain or logical chains, right? Conditional chains. Sorry, I don't know what just happened there. Conditional chains. But if we add more else ifs in there, it'll get very, very messy, very, very fast, right? It'll just go like all the way to the right. Probably you'll have to scroll, like that horizontal scroll bar will pop up, and it's just awful. So unfortunately, we're just gonna have to live with this. There's no way to deal with it in Python. So yeah, just kidding. Obviously, I'm just kidding. No, the Python developers are not that cruel. They gave us a way to deal with this. And that is the elif keyword, right? So this elif keyword works exactly as you would expect. It's just like else if, except you don't have to deal with that nasty white space anymore. So it is worth mentioning that these conditional chains, they work exactly the same as in other languages, right? So as you would expect, you can only have if at the top. You can't have if somewhere within, otherwise that's a new chain. You can't have elif at the top. You can only have it with between if and else, if there is an else. And you can have any number of elifs that you want, and you can only have one else. So that's all, nothing new. Works exactly the same as in other languages. Okay, are there any questions on that? I realize that was kind of fast, but we're assuming some CS31 knowledge, so shouldn't be anything new. Don't be shy if there is anything. All right, I think we're good. So let's move on. So up next, we're going to talk about loops. So first up, let's talk about while. While is, again, nothing new, pretty much the same behavior as before, except it's a loop, right? I mean, compared to the if statement or the if conditionals, right? One thing that is different, though, is that there is no increment or decrement operator in Python. So we're stuck using plus equals 1, minus equals 1, which is kind of annoying. I'm not sure why there is no increment or decrement, but it is what it is. So yeah, here's an example of the syntax for a while loop. You can see that there's that condition there. And while that condition is true, this is going to keep executing. And this actually brings up a good opportunity to talk about truthy and falsy values again. So you can assume that this number, this num ingredients, is some integer value, right, that is greater than 0. And while it is greater than 0, it's going to be truthy, right? It's going to be converted to true because it's not 0. When it eventually becomes 0, it's going to be falsy, and then it will terminate this loop. So it's going to result in printing lost ingredient, however many number of ingredients there are, right? Okay, on to the for loop. So the for loop it actually gets a bit more interesting. It's a little different from what you might be used to. Instead of that initial condition and then like the terminating Boolean condition and then the step, all that stuff that you do in C++, it's really simple. All it does is it just iterates over the items of a container, right? And if you're familiar with for each loops, that concept in other languages, that's basically what this is. So let's just take a look at the syntax you might use. So this is a container, right? And then this is our iterator that we're defining here. So we're calling our iterator word. And for each iteration of the loop, it'll be set equal to first the first value in the container, then the second value, and then the third value. So this will end up printing anyone on one line, can on the next line, and cook on the last line. Right? Okay. And this looks great. It can be really convenient because there are a lot of cases where we need to iterate over the items of a container, right? But sometimes we want to do something a particular number of times. Sorry, someone's outside. We want to do something a particular number of times. And so how do we do that in Python? Do we have to make a list of all the numbers that we want to iterate over? Like, is that, like, do I have to make, like, say I want to iterate over something 5 times. Do I have to say for like I in 0, 1, 2, 3, 4, 4? Like that would, I don't know, that seems a little inconvenient, right? Basically, that is what you do. But luckily, it is built into the language. So we use what's called the range function. And the range function just takes in this input you can see up here, which I'll go over in a second, and it returns a range object, which is just a sequence of numbers that you define using these parameters, right? So up here, you can, if you want, you can only input one number. Say I want to count to 5, or up to but not including 5. I can put 5 in here, and then it'll go from 0, 1, 2, 3, all the way up to 4, and then it won't include 5. Okay, so this is going to be an exclusive value. I can also define a start value if I want. So if I want to say, for example, start at 1, I can just call this 1, and then call this 5, and then I'll go 1, 2, 3, 4, and stop before 5. This step here, but what's indicated by these square brackets is just the fact that this is an optional parameter. You don't need it if you don't want it, but you can, if you want to, define a step. So if you want to only have, if you want to count by 2s, for example, you can just throw a 2 in there, and then it'll count by 2s. Okay, so let's look at an example of that. So here it is. For num in range 10, this returns a sequence of numbers from 0 to 9, right? 10 is excluded. And this is obviously going to be an iterable sequence. So it'll iterate through each one. It'll have the value 0, 1, 2, 3, and then it'll print all those out on separate lines, right? That's pretty simple. This one is a bit more complicated. This one, it defines the start value as 20, and then the stop value as 10. Remember, this is going to be excluded, and then the step is going to be -2. So if you want to ever count down, this is how you do it. You just define a negative step value, right? So this is going to print out the numbers from 20 all the way down to 12. Remember that 10 is going to be excluded. That's why it's 12 and not 10. Okay. So Python has a ton of really, really cool looping techniques. It gets way more complicated than this. Trust me when I say that. It gets very complicated and very concise, very elegant. And we're going to be going into that next time, not this time, because we don't have unlimited time. So yeah, just wait until next time. Your mind will be blown by the cool stuff that you can do. So yeah, look forward to that. Okay. Are there any questions on any of that? Again, I realize I'm kind of zooming through, but don't worry. I'm going to slow down in a minute when we get to some new stuff. Okay. I don't see any questions, so let's just keep going. All right. So on to functions. So the main way functions differ is in the immense flexibility of the parameters, and we'll get to that in a minute. But first, let's just show the basic syntax. So up here, we have this def keyword, which indicates that you're defining some function. And then we give it this name, f, it can be whatever you want. And then we also give it some number of parameters, in this case, x and y. And then again, you use white space to indicate the body of the function and a colon up here. Okay, so x and y can be any type. Whatever you want to pass in, you can pass in as long as it's compatible with whatever you're doing in the function. So say, for example, you pass in a list for x. You can't then also expect to be able to multiply that list by 10 because it doesn't make sense to multiply a list by 10. Or say, a better example, x and y are both lists, and then you want to multiply x and y. That's not going to work. It's just not defined in Python, right? Actually, I think that you can multiply a list by 10 if I remember properly. You can multiply a list by 10, so ignore that I said that. But yeah. So the return value is specified with return, just like in other languages. Implicitly, if you don't define a return value, it's always going to return none. So none is just the analog to null that you've seen in C++. Okay. And it's really important that you remember your mutable and your immutable types, because this comes up it's especially important with functions, because when you pass in immutable types to a function, they're always passed by value, meaning that if you change them within the scope of the function, they will not be changed outside the scope, right? So say you pass in some integer variable, and then change it to 5, but its original value was 3. After you exit that function, the value will continue to be 3, right? However, if you pass in some mutable type, like say a list, if you change some values within that list, then they will continue to be changed after you exit the scope of that function. So yeah, remember your mutable, your immutable types. That's important to know. Okay. And here's where it starts to get a little more interesting. So in Python, functions, like I said, are very flexible. So you can do the standard, what's called positional arguments, where you just pass in, for the first value, for the first parameter that you define, in this case it's x, you just pass in some value. So x will get 42. And then hello there, this list is passed in for y. And that's just the standard positional arguments that you're familiar with. You can also do something called keyword arguments. So with keyword arguments, what happens is you can, instead of just passing in at the position of the argument, you say the keyword, you specify which parameter you're passing to. So you can potentially, like as you can see here, pass in values out of order from the original way that you declared them, right? So here you can see I'm passing in y first, I'm giving it hey, and notice that that is a different value, a different type from this. That's totally legal. And you can also do the same thing, just give x 99. You can also mix the two. So you can have this first positional argument here and then this keyword argument. That's totally legal. What you can't do, however, is place positional arguments after keyword arguments, right? Because that makes it difficult for the interpreter to know which value you're trying to specify. So if you say, for example, fx equals hey here, and then you just specify 99, you don't say this y equals here, it won't know if you're trying to give y the value of 99 or some other parameter. It just isn't sure. So you always have to make sure that there are no keyword arguments coming after, or there are no positional arguments coming after keyword arguments. Okay, cool. So again, Python parameters or function parameters in Python are very flexible. So let's take a look at print in some closer detail. So I went to the Python documentation and I pulled this up. And if you're like me, it was like, wow, what is going on? What is this stuff? So let's just break it down one by one. So first up, this objects thing here with the asterisk before it. It's kind of confusing because I thought there were no pointers in Python, like what is going on here? Well, all this is something called an arbitrary length argument list. And that's a huge mouthful. So I'm going to call it an ARBs for short, or an RB for short, because I cannot say that over and over again and not mix it up. So yeah, ARBs. Yeah. So what an arbitrary length argument list is, or an RB, is it allows you to pass in any arbitrary number of arguments that you want. So I think it's easier to, rather than explain what that is, just show it in action. I'll show you what the print function can do. So say I want to print, I can obviously do the standard hello. And by the way, I'm in VS Code right now. And instead of the interpreter, just because some of the things I'm going to do later are more convenient to do in VS Code. And the way to execute these scripts in VS Code is just to call Python3 of whatever your file name is. In this case, it's args.py. So you can see hello, that's nothing new, that's standard. We can pass in a ton more arguments if we want. Any arbitrary number due to that arbitrary length, due to that RB. I keep forgetting to call it RB. So I just say hello world, rat tat sick, dope. Yeah. And then I can rerun that. And you can see that it runs, it prints this. It prints this, all these strings separated by spaces, right? So you can have literally infinite number of conditions here. So let me just copy that over and over again. And then you can see if I run this again, it'll work just the same. And that's pretty awesome, right? It's really flexible. It's really cool. And it's all made possible because of this RB here, right? Yeah. Okay, so that's the RB. Let's now talk about these here. So these are default arguments, right? We're assigning these arguments to have some default value, meaning, or that which results in them being optional, right? So you can see I don't even call them here. I don't, honestly, you could probably not even know that they exist, which probably most people don't know they exist, right? And you'd be fine, you'd get along just fine. So you can also, you can call them, or you can pass values to them, but again, they have to be, or not again, they have to be keyword arguments, right? So you have to specify sep. And then say I want to separate it with, let's just do that, or yeah, whatever. So if I call this again, you can see that they're all separated with this little string here. So that's pretty cool. And I do want to emphasize that all these arguments that come after the keyword or the RB, those are keyword only arguments, meaning you cannot pass just a simple, you can't just pass that and expect it to work, because it'll just get appended to the end of the print statement, right? So you have to specify that it is being passed to sep using the keyword. That's what I mean when I say it's keyword only. Okay, I'm actually just going to skip over all this other stuff. You can go to the documentation if you want. I do have a link in the slides. So yeah, check that out if you want. But the important stuff to take away here is that this is an RB, meaning an arbitrary length argument list. These are default parameters, so they're optional. Okay, so let's do some more examples. I'm just going to comment this out. By the way, a comment in Python is just a hash there. Let me stall a bit so I can find my example. Okay, here we go. So I'm going to design a function that will take an arbitrary number of strings and return the results of them all concatenated. That's a long word. I don't know if I spelled it right. Concatenated together. Please roast me if I spelled that wrong. Okay, let's call this, oh yeah, and I missed something important. They're all separated with a specified string. Okay, so this is basically going to be the analog to print, except instead of printing, it just returns the string, right? So I'm going to define function. I'm going to call it concat because that's what it does. And I will then I will define some parameters. So first up, I know since there's an arbitrary number of parameters that we want, I'm going to give it an RB here. And again, this name is arbitrary. It doesn't matter what you call it. Before up here in the print, it's called objects. I'm calling it args. It doesn't matter. You can call it whatever you want. But you do need this asterisk here to indicate that it is an RB. Okay. So, and then I also want to specify the separator. So I'm just going to give it a default value of empty string. So it'll just separate them with nothing by default. And then luckily, you'll notice this happens a lot in Python, where you go to design a function, you go to make a function, and it's built in. It already exists. So I'm just going to return the result of sep. I'll explain what's going on after I finish it. The result of sep.join args. So this join function is a member function of strings. So you can call it on any string variable, and you pass in some list. So this args is going to be a list, right? You pass in some list, and what it does is it combines them all together into one string. So what this will do is it'll do exactly what we say up here, right? So let's call this function then. So we have a lot of flexibility. So I can say concat of call back to Ratatouille. Anton Ego is a jerk, and that will. Oh, I have to print this out to actually see it, since I am. This is a return value, right? So if I run this again, I get Anton Ego is a jerk separated with nothing. So it's all just like smushed together, right? Then if I want to separate it with spaces, since this is a sentence, I can just say that. But notice that, I put it in the wrong place. Here we go. So notice that I do have to invoke this as a keyword argument. So there you go. Works as expected, looks great, awesome. And note that when I say arbitrary, I really do mean arbitrary. You can pass in no arguments if you want. So I can say print concat of nothing, and that'll just print an empty string, right? So you can have literally any number of arguments that you want. Okay, let's go back to the slides. All right, up next, let's talk about functions as first-class objects. So what that means is that functions can be assigned to variables, and functions can also be passed as arguments to other functions. So they're treated just like any other object. That's why they're called first-class objects. They're treated just like any other object in Python, in the language, right? So let's get a look at this. Move back to VS Code, and let's do just call a function. Just do this quickly, f of x, and returns x squared, okay? And then just for the sake of demonstration, I'm going to set this equal to a variable called f. And then if I do print g of 5, this will return, if everything goes well, this will return 5 squared, which is 25. So let's take a look. I have to rename that firstclass.py. And you can see it does return 25, or it prints 25. So that's perfect. So we can pass, or we can rename essentially these functions. We can give them more names using this behavior here. Okay, and let's also show how you might be able to pass them around as arguments. So I'm just going to comment this all out. There you go. And I'm going to define a function called transform. And again, these are all arbitrary. I'm just doing it for the sake of demonstration, which takes some function, let's call it fun, and also a value x. So it's going to transform x by that function. So let's just return the value of that is returned by calling x of that function. Okay. And then let's also define some other value. Actually, I'm just going to uncomment this out. And then I will call transform by, and then pass in that f up there. And then if I do, say, 5 again, that will return. Oops, I did not print it. Oh, God. Print. Sorry, my Zoom is acting up a bit. Here we go. Here we go. So it prints 25 because that is what this function does. We pass in this f here, and it returned the value returned by that. Notice how we did not call it here. We didn't include parentheses here because when we include parentheses, that indicates that we are calling the function. That's not what we want. We want to pass the value of that function, or we want to pass technically the pointer of that function, right? So we're passing that function into this into this other function, and then that function, this function f, is being called by that other function. So we're never actually calling the function f ourselves. It is all being done by this function here. Okay, so I think that is pretty much it for all the new content for this week, for this week. I do want to give you a quick sneak peek of some stuff we're doing next week. When I said it was wild, I meant it. Like, look at this. This is something called list comprehension. And if it looks insane, it's because it is. It's basically a way to do something that you do very often in other coding languages in a very concise way. If you want to look into it more, I'm not going to talk about it right now. If you want to look into it more, definitely look it up. But we will be talking about it next week. So I do recommend that you come out and listen. So yeah, that's pretty much it for this week. Thanks for coming. Next week, we're covering a lot of interesting stuff in addition to data structures. So that will be the 14th, always at the same time, 6 p.m. to 8 p.m. And as always, we would really appreciate it if you fill out our feedback form. We really, really appreciate it when you fill it out. And as some incentive, we will be giving out some money. So free money, fill it out. It'll take like 5 minutes, so probably less actually. So yeah, appreciate you guys. And that's pretty much it. So thanks for coming out. Okay, I will put on the music again as we're all filing out. And I'll stop recording.